Hi everyone, chapter 8 will cover some basic inferential statistics using R programming. So the first basic inferential statistic that you need to know is testing one parameter value. So actually the testing one parameter value can be divided into two, parametric and non-parametric. In this case I will only cover on the parametric test. For one sample t-test, we will test whether parameter value, which is mean, is true or not with assumption data is normally distributed. So the null hypothesis mu equal to mu null versus the alternative hypothesis mu not equal to mu null, or mu greater than or mu less than. So assume that the standard deviation is unknown, then the test statistic follows the t distribution, and then this is the 100 1 minus alpha % confidence interval for mu. Okay, for example, the volume of mineral water sell at supermarket supposed to be 600 ml per bottle. A random sample of 10 bottles of mineral water was selected and measured. The volumes recorded are as follows. So this is the data in milliliter. The quality manager at the hypermarket detected that the volume of mineral water is more than 600 ml per bottle. Test whether the claim made by the quality manager is true or not at 5% level of significance. Okay, so this is the basic step of the hypothesis testing. So step 1, okay, is the hypothesis statement, the null hypothesis. We assume that the parameter value is true, mu equal to 600, versus the alternative hypothesis mu greater than 600. Okay, because of this statement, the quality manager at the hyper supermarket detected that the volume of mineral water is more than 600 ml. Okay, for the test statistic, we use the t-test. See, this is the formulation. Okay, let's say we copy the data first. Okay, the data is in a vector form. So there are 10 observation run. Okay, and then we want to compute the test statistic. Okay, so we use the, actually this is based on this formula, x bar minus mu divided by standard deviation over square root n. Okay, so you can write t calc is equal to the x bar mean of water, okay, minus the parameter value, which is 600. Okay, put a bracket, divide by standard deviation of water, put a bracket, over square root sqrt, the length of water. Okay, run. Oh sorry, I forgot to put the bracket here. Okay, so the value of t calc, if I run here, the t calc value is equal to 2.392073. okay, and then find the critical value. Okay, so since the area of rejection is on the right hand side because the alternative hypothesis mu greater than. Okay, so we find the 1 minus pt. Actually pt, the R programming will determine the value of probability less than is on the left hand side. Okay, so since in this case, okay, the testing is on the right hand side. Okay, it's a right tail test. So we compute the probability value by 1 minus the probability of t cut less than 2.39. okay, so 1 minus pt, okay, t cut, okay, degree of freedom is length of water minus 1. okay, so run, you get the probability value is equal to 0.0202099. okay, and then how to make a decision whether to reject the null hypothesis. Okay, the p value that we obtain here 0.0202099 less than alpha equal to 0.05, therefore reject the null hypothesis, and then conclude that there is no evidence that the mean volume of mineral water is more than 600 ml per bottle. okay, and then you can also use a built-in function quality test to conduct the hypothesis testing. okay, so we use the t.test function. okay, so t.test, okay, put the data which is water, okay, and then we want to test mu equal to 600. okay, and then alternative, okay, so let's say alternative is greater. okay, and then we can decide the level of confidence. okay, confidence levels, let's say 0.95. okay, and then run. okay, so you will get the same p value, okay, 0.02021, the test value 2.3921. okay, the same interpretation. okay, and then since the test is one-sided, so R will return a one-sided confidence interval. If you can see here, 95% confidence interval. okay, it will return only on the one-sided confidence interval. okay, so if you want to get the lower and upper limit, the 95% confidence interval, okay, then you can use this confidence. You can copy this one, paste. So instead of greater, then you can change into two-sided, two-sided. okay, so that it will return the lower and the upper limit. So we can say that on the average 95% confidence interval, the mean of the volume is between 600 to 603 milliliter. okay, so this is how you interpret the confidence interval. okay, and then you can also construct the confidence interval, okay, the lower and the upper. okay, actually you will get the same thing by using this formulation. okay, so I just copy paste this one, okay, because I want the value of lower and the upper limit in a vector form. okay, so that's why I put them in a vector form. okay, so for lower, okay, x bar minus, actually this is t alpha over 2, degree of freedom n minus 1 multiplied by the standard deviation over square root of the length water. This is the lower limit. For upper limit, okay, the mean, the x bar plus, okay, the t alpha over 2, degree of freedom n minus 1, standard deviation over square root n. okay, so if I run this one, okay, so I will get the lower and the upper limit. Actually this value is the same as this one. okay, this one, okay, the value that you obtain by using the function of t-test. Okay.